In this video, we're going to be looking at question 12 from the Further Maths GCSE paper for 2022, paper 1. So we've been given an nth term of a sequence, 3n squared over n squared plus 2, and we've been told that one of the terms in the sequence is 32 over 11. Work out the value of n. So we want to work out when 3n squared over n squared plus 2 equals 32 over 11. So we're going to have to rearrange and solve this equation. Now I'm going to start by multiplying both sides by 11. So we're going to end up with 33n squared over n squared plus 2 equaling 32. And then I'm going to multiply both sides by n squared plus 2. So on the left, we're going to end up with 33n squared. On the right, we're going to have 32n squared plus 64. So I just go back up here for more room. I'm going to rearrange to get n on its own. So I'm going to take away 32n squared from both sides. Those are going to cancel. So we're going to end up with n squared equals 64. I'm going to square root both sides. So n is going to be plus or minus 8. But as we're talking about an nth term, we know that this term has to be a positive integer. So we are only interested in the n equals 8. Now there's a part B to this question. Write down the limiting value of the sequence as n tends to infinity. So our sequence is 3n squared over n squared plus 2. Now, as we send n to infinity, this 2 here becomes more and more insignificant to the point where it doesn't really play any value in the fraction. So as n tends to infinity, our sequence will only take the form of 3n squared over n squared. So we can kind of do a little cheat and kind of ignore that plus 2 and now simplify this fraction. So we'll divide both top and bottom by n squared, so we're going to end up with 3 over 1, which is the same as saying 3. So as n tends to infinity, this sequence gets closer and closer to this value 3. And we call that our limiting value.